So I have the honor of introducing Travis Johnson, who is the Global Product Lead for Garmin Health, who's responsible for the digital health product and services roadmap at Garmin and strategic partnerships across the corporation for corporate wellness, population health, and patient monitoring. Travis. As well as Dr. Mark Clements, who is a pediatric endocrinologist specializing in the care of children and families with type 1 and type 2 diabetes. He is also the Director of Endocrine and Diabetes Clinical Research and the Medical Director for the Pediatric Clinical Research at Children's Mercy Hospital. So welcome. I'm just going to tell you, I'm like, we need to get to lunch, so I put pressure on Mark and said, speak really fast for me. So he told me he could shave a little bit, but not the whole slide. So I'll hand it over to them.
Yeah, I realize that we're the only thing standing between you and lunch now, so I will try to go through quickly. First, I'd just like to say, thanks for the opportunity to be here and speak at PEDS 2040. It's my first time here, and I'm excited to share a little bit of Garmin's story and what we're doing in the health and medical space, as well as be up here with our friends from Children's Mercy and talk through a really interesting case study, I think, of what a consumer wearable company can do with a great innovative organization like Children's Mercy. So first you might be wondering, what even is Garmin Health and what is Garmin doing up here talking? Well, with that great introduction, it's my responsibility to help lead Garmin's efforts in the health and medical space, responsible for the roadmap of what we're doing in the regulated software medical features, right? And so as part of that, I take a look at finding strategic partnerships and alliances and help lead the actual development of what we're doing in that space. So again, you may know nothing about Garmin. Garmin is a company that's been around for 30 years now. We're celebrating our 30-year anniversary this year. And we're actually headquartered in Kansas City. We've got about 14,000 employees in over 60 different countries and actually got our start making GPS units for aviation. Right? So we're a highly diversified company across these 5 different segments. And you may think of us as that GPS unit that was stuck in your dash in the 2000s and early 2010s, but we're so much more than that, and the 5 markets that we're across have us developing products from laser bow sights to dog collars to glass cockpits to, autopilots for boats and on and on. And along with that, of course, we make wearables, and I love this slide because it really shows the evolution of what has happened to wearables over the years. That first one in 2003 was, I think of it affectionately as a brick that you could wear on your arm, and I'm sure it was super comfortable. But it was revolutionary at the time, right? You didn't have a good way to get pace information or distance from your run. You would do things like drive your car around and see if it was actually 5K or not so you could train. And this was the first way to really objectively quantify what you were doing for your training. And I mention that because that's what we want to do in the health and medical space as well, right? Garmin is an engineering company at heart. We do super fun buzzword of vertical integration and try to find an icon that fits vertical integration. I challenge you to find one that's better than that. Little boxes moving on an assembly line. But what I mean by that is that Garmin does all of our own engineering and manufacturing, right? So we understand our products down to the component level. And because of that, we can more easily make validation claims and are willing to speak to the validity of our data that we create from our wearables, create water-resistant wearables that are easy to wear. A lot of them have a battery life of over a year, down to 7 to 14 days, which means if you're looking at a patient or even just on a personal user level, right, it's really comfortable to wear our devices, and they can create that really rich stream of objective, continuous data that's valuable for so many different applications. So Garmin Health. We are definitely the part of Garmin that is responsible for looking for use cases of our wearables across a diverse set of markets. And it was mentioned here in the introduction, but we cover solutions from corporate wellness to population health and to patient monitoring. But what I want to know about Garmin's strategy in those markets is that we're not trying to be the solution, the end-to-end solution for all of that, right? We know what we're really good at. We're good at making hardware. We're good at making wearables. We're good at standing behind the claims that we can make about that data. But we're not necessarily the experts in analytics or the experts in engagement or on, and certainly not the experts in clinical applications of it, right? And so we're looking for partners in all of these spaces to help bring like collaborative solutions to market. And I just mentioned a few partners up here. Most of these are health and life insurance companies kind of around the world. I could have made 100, 1,000 different slides of these. But I want to point out here that there's a lot of correlation in what we're doing in the insurance space around validating the claims that we can make from data from consumer wearables, as there will be over on the clinical side. So as Garmin has entered in that health and medical market, it's been super important for us to start to develop features where we can make clinical claims. And one of the first things that we rolled out was our advanced sleep feature, which was the ability to estimate REM, deep, awake, light sleep, sleep onset, sleep wake periods. And we did that by sending home sleep profilers with a bunch of users, logging all the clinical data, doing the same thing from our devices, and then developing those algorithms based on what we could see. And the results were that, we can claim we have about 70% accuracy on estimating sleep stages compared to two sleep technicians, which it's my understanding that the gold standard is only about 80% agreement between the two, so really not that bad. And thinking about that, right, it's perfect for longitudinal studies. It's perfect to give some sort of quality assessment on the data long term. And while maybe not as accurate as an in-sleep clinic, it's certainly easier for users to wear a device than go to a lab. So I'm trending towards some different medical features here, but the next thing Garmin did then thought about, well, what else would users want to know about their sleep? Well, it's important to understand how well you're breathing and your O2 sat levels at night. And so Garmin built one of the first pulse oximeters into a consumer wearable that actually provides you the full percentage values, not just relative trends. And we rolled that into one of our largest smartwatches, although obviously it's not as big as the picture makes it look there. But turning on that ability to see how well you're acclimating to elevation changes. And we very quickly rolled that into our smallest wearable, which I think you'll see this wearable show up on slides later as well. And build that same pulse oximeter into that lets you see how well your body is adjusting to oxygen levels at night. Again, more indications and insights around sleep hygiene. But of course, there's an aim for that. There's a plan. We're not just willy-nilly putting sensors into devices and developing features. There's a goal. And our goal for that, right, is to build software as a medical device features. You've heard the FDA talk about it. There's really promising initiatives in the digital health side of that. And that concept, again, is that it's not the device itself that has to be regulated as a medical device. It's the software component, the feature, the algorithm, whatever it is that goes into it that performs those medical functions. We recently presented at Sleep 2019 with our research partner on some research that we did related to sleep apnea risk assessment. And I have to verbally correct some of the numbers up here. I think it was actually 91% accuracy with a little bit different sensitivity and specificity, which we will eventually publish. But at the time, this was the data that we had. And we found that we could very reliably tell someone if they were at risk to moderate to severe sleep apnea based on the detection of ODI, and that's in relation to actual AHI. And then, of course, the obvious applications that we already see in the market, being able to detect, identify irregular heart rhythms like AFib by continuously monitoring data from the users from the wrist. And really, that's just the start of everything that I think we can do. And I've heard so many examples, even just being here at this conference, of applications for wearables. But I think one of the interesting things, and that Dr. Clements will talk about here, is just even that activity level can be super useful in treatment of particular conditions. So with that, I will turn it over.
Thanks, Travis. So it's my pleasure to be here with you this morning, and I want to thank Dawn for the kind introduction. This is a fantastic conference, and I learn so much from it every time that I come. So we have several colleagues, including myself at Children's Mercy, who've been thinking a lot as we develop a partnership with Garmin and how to apply these fitness wearables to the monitoring and treatment of chronic disease. So we have sleep specialists in pulmonology, we have gastroenterologists and cardiologists, and I'm in the diabetes center. Just a little bit about myself. So I play several roles. I run diabetes and endocrine clinical research at Children's Mercy. I run the clinical trials unit for the hospital. I participate in several large registries. The Type 1 Diabetes Exchange is a globally connected health outcomes registry. And the Type 1 Diabetes Exchange Quality Improvement Collaborative is a collection of diabetes centers that are trying to quality improve pediatric and adult diabetes care. So we really are thinking about how to change care in the clinic, at the bedside, every week. So let me tell you a little bit about type 1 diabetes before I get started. So first, remember that it is an autoimmune disease. It affects children and adults. 40% of people diagnosed across the lifespan are diagnosed after the age of 30. There are 166,000 youth in the United States who are affected. We have 18,000 new cases per year in the U.S., and there's an incredibly heavy burden of self-management for this disease. I think of the disease as a cage. Really, if you are a child with type 1 diabetes, you have to engage in upwards of 18 to 24 individual self-management behavior episodes per day. So I would like you to go home today, and I would like you to set an alarm on your iPhone or Android phone to go off every 45 minutes and ask me whether that annoys you, or tell me whether that annoys you. We also know that exercise is extremely important to the management of both type 1 and type 2 diabetes. I shouldn't have to convince you of that, but I'm going to try to paint you a picture for how I think that this information from fitness wearables can really inform our disease management in perhaps some ways that we haven't imagined before. In addition to exercise information, there are other things that we don't routinely measure in clinical practice right now. One of them is food. We don't measure routinely in diabetes care what somebody's eating on a daily basis. And it turns out that both of these behaviors actually make up 2 of the 7 pillars of diabetes self-management for children and adults with type 1 or type 2 diabetes. So being active is one of the pillars of self-management, and we do not currently routinely monitor it with any objective measures. It turns out that it's so important that we have consensus statements based on the limited evidence that are available in the literature to guide our decision-making and how best to support youth and adults with type 1 diabetes while they are exercising. And we need to gather more data. As a matter of fact, we're part of a multinational study that is using Garmin devices in order to measure physical activity using accelerometers and heart rate monitors so that we can inform future decision support tools on how to guide patients when they're exercising, and also to inform the future design of a device called the hybrid closed-loop artificial pancreas that will, we hope, in the future incorporate physical activity data in its algorithms to guide automated insulin delivery. So those are the ways we already know that we need to be using fitness information, but there are other ways in which we could use exercise data. So on the left here, I show you an image from the ESPN ball tracker, and I show you that just to demonstrate that if I'm an outfielder, when I see the batter hit the ball, one of the things I'm doing is I'm making a calculation in my head, and I'm trying to predict what the trajectory of that ball is, right, so that I can put myself in place to catch it. I'm not really a baseball player, but in my adult life, I am a pretty good kickball player. I've actually been in several adult kickball leagues, and a little bit of trivia is that I have a Lifetime Achievement Award in kickball, believe it or not. So we did the same thing, right? We placed ourselves in the outfield, and we try to put ourselves in position to predict the trajectory of the ball so we can catch it. That's essentially what we want to do in the management of chronic disease. We want to put ourselves in position to identify the trajectory of self-management, the trajectory of outcomes, so that we can catch that patient before they fall. So this graphic that I'll show you is from a presentation I gave in 2017 at the American Diabetes Association conference that just shows that we have, across developed nations in the world, tremendous variation in the percentage of patients who are meeting their blood glucose control targets. And you can see that the United States is actually one of the lower achieving nations, and that there is also, if you look at the width or height of the orange bars, there's actually variation from center to center across the nation. So we have a lot of work to do to quality improve this. This next graphic comes from the Type 1 Diabetes Exchange, and it demonstrates that we are also doing a very poor job in the United States of helping our pediatric and adult patients meet their blood glucose control targets. So the target for hemoglobin A1C, the major biomarker of control, is to be less than 7% if you're an adult, or less than 7.5% if you're a child. And you can see that not only are most people not meeting that target, as indicated with the median hemoglobin A1C achievement on this graph, but then in pediatrics, we have a tremendous deterioration in blood glucose control, as you can see on Mount Kilimanjaro on the left there, and that there is a significant rise or deterioration in blood sugar control. This graphic shows, using a technique called latent class analysis, that we can actually predict which kids are going to have deterioration in their blood sugar control. The problem is that I have to do a lot of data collection and data curation every day in order to run these kinds of models. It's a heavy lift. It usually takes 6 months to a year to develop a project like this. And we need to be making these kinds of predictions every day so that we can identify the 20% of youth who are really at risk for deterioration. So we have used, in partnership with the Helmsley Charitable Trust and our colleagues at a company called SIFT, a group of machine learning and natural language processing methods to predict worsening blood glucose control over the next 90 days. In our initial model development, we've used ensemble methods, including random forest and decision tree, along with natural language processing of clinic documentation and the electronic health record. And our initial model, using just EHR data, was able to provide us a 55% precision in predicting which youth will have a very significant rise. And so that's an enriched population. It's not perfect, but it's an enriched population. If we include self-management device data, which includes insulin pumps, glucose biosensors, glucometers, smart insulin pens, data that we can and should get access to, we can actually improve that to a 70% precision. We're also developing models currently to predict which youth are at the highest risk for returning to the hospital with diabetic ketoacidosis, one of the major acute complications of type 1 diabetes. And so we're using, again, the dirty, messy, raw, partly reliable, and very diverse data from the electronic health record. We have recently developed a model using a recurrent neural net approach, and we have found that we can achieve a 100% precision for the top 10 highest risk individuals for returning to the hospital with diabetic ketoacidosis every time the prediction is made. And we're aiming to make the prediction every month. So the top 10 individuals out of 2,150 that we provide care for. The next thing we're going to be doing is developing a model to predict the amount of time between now and their next admission. And we're going to put the two of those together to actually implement quality improvement projects. So what are we doing with that information? We're actually trying to pair them with interventions that we know work. So what you see up here is what we conceptualize as a toolkit for type 1 diabetes care. And we think it starts with predictive analytics and population health management to risk stratify our population, and then better matching with interventions that will work. And we think that fitness wearables from Garmin can both help us in predicting outcomes and can be a part of the toolkit by which we treat individuals who are at high risk. So with that, I'll stop and just mention that we are incredibly enthusiastic about the developing relationship between Children's Mercy and Garmin Health, and we hope to improve care across several disciplines. Thank you.